Regents exam, Algebra 1, August 2016, problem number 17. The table below shows the temperature, T of M, of a cup of hot chocolate that is allowed to chill over several minutes, M. Which expression best fits the data for T of M? In this problem, we are asked to determine which of the four expressions given best fits the data from the table. Since the question is asking us to determine which expression best fits the data, we need to analyze the data in the table, along with the expressions provided. Notice that the expressions for all four options represent exponential functions. Recall that an exponential function has the following form: f of t equals 8 times the quantity 1 plus or minus r raised to the power of t, where a is greater than 0. There are two types of exponential functions, growth and decay. If the quantity inside the parentheses, which represents the base of the exponent, is a number equal to or greater than 1, then the function represents an exponential growth function. On the other hand, if the quantity inside the parentheses is a number between 0 and 1, then the function represents an exponential decay function. If r represents the rate of growth expressed as a decimal, then we would use the exponential function with the quantity 1 plus r to model an exponential growth function. If r represents the rate of decay expressed as a decimal, then we would use the exponential function with the quantity 1 minus r to model an exponential decay function. In both exponential models, a represents the original or initial value and t represents time. Notice that all the options have 150 as the original or initial value, so we can't determine or answer solely based on the original or initial value. We need to figure out a different way to determine the expression that matches the data. With this in mind, let's analyze the data and figure out whether the data can be modeled as an exponential growth or exponential decay function. Notice that the temperature is going down as the number of minutes pass by. This is characteristic of an exponential decay function. As time progresses, the temperature of the hot chocolate becomes colder. With this observation, let's determine which options represent exponential decay functions. We're looking for functions that contain a number between 0 and 1 for the base of the exponent. The first and third options have a value of 0.85 for the base of the exponent, so these options represent exponential decay functions. Options 2 and 4 have a value of 1.15 for the base of the exponent, so these expressions represent exponential growth functions, so we can eliminate these two options. Now we need to determine which of the exponential decay functions best fits the data. We can figure this out by selecting an ordered pair from the data and substitute it into the expression and check to see if it yields a true statement. Choosing the point 0, 150 and testing the expression from the first option, we go ahead and substitute m with 0. Make sure you follow the order of operations. We first need to simplify the exponent, then multiply the result. We also need to remember that a number other than 0 raised to the power of 0 is equal to 1. Simplifying the expression, we obtain 150. So this point yields a true statement. So we can conclude that option 1 is our answer.